Okay, good morning or evening, everybody. Welcome to the cab call for this month. I am guest emceeing today as Troy had a conflict, although Troy's on audio for the beginning of this call. And
Okay.
hi, Troy, and congratulations on your new role as Extensions PMC lead.
Thanks very much. I won't have an update today, though, I'm afraid.
That's quite all right. Quite all right. Yeah, I'll reach out to you this week and we can talk about that and getting stuff rolling there. So cab call. We've got Summit next week. I'll be starting off with the CFF highlights. Summit next week. You probably all know about this. It's very exciting. The schedule is up. Looks like we've got some great breakout sessions. We also have afternoon hands-on labs, which were added a little bit later in the schedule. If you haven't taken a look at those, I highly recommend it. We've got some, I'll briefly talk about those because I don't think that's been discussed here yet. But we've got some great labs. We've got a CF for Kate's deployment lab. We've got a kubecf deployment lab. We've got a lab from the CLI team on new features in V7, which should be pretty awesome. And then Steve Greenberg will be running through Try Cloud Foundry for total newbies. So yeah, it's a nice little curriculum. Oh, and then of course, Project Gluon from Stark and Wayne, which you'll be seeing a presentation on during this call. James, you good to go for that today? I'm sure you are. Cool. Does anyone have any questions about Summit? Obviously I can answer questions about the labs. If I can't necessarily answer all of your questions about Summit because this is the first time we've done an event like this, but anyone have any questions or thoughts on Summit?
I'm assuming folks can register right up until the event starts, even?
I assume that as well. Yes, I don't think that's gated at any point. I assume you can sign up an hour into the event. I'll double check that though, because that seems, it's always good to ask questions early. And of course, if anyone does have questions that pop up, just reach out in the Summit Slack channel in Cloud Foundry Slack. And hopefully we can get all of your questions answered there. First time doing a virtual event, of course. So, you know, it'll be interesting, but I'm looking forward to it. Not as much as I would if we were all going to be hanging out in Austin or some other locale, but should be good. With that, that's all we've got from the CFF. So I will move on to PMC project highlights. Eric, you want to talk about some things happening in the app runtime, PMC?
Yeah, happy to, Chris. Just to cover some highlights from the past month or so. We've had new releases from both of the teams that are getting the app runtime deployed onto Kate's. Relevant has released version 0.3 of CF for Kate's. I know they have some improvements to upgradability and configurability. I think at this point now you can bring your own certs for ingress gateways in that. And then kubecf has released, I think the latest version is 2.2.2 there. And I know they've been getting some bug fixes into that. And they're also focused now on incorporating the UAA's deployment artifacts to Kate's as part of that set of resources. One thing also that's coming up is, in fact, I think Josh Collins just posted to CFDev about this, but the CLI team is just about to release the first GA of the V7 CLI. So they had some details there about how the transition for things like the homebrew taps for distributing that and what people can expect there. Some other component team highlights. Cab1 team is, I think, just finishing up work on kind of the next phase of their integration of KPack. So this is going to allow them to integrate the Paketo build packs as more granular build packs into CF for Kate's as part of that set of build pack resources. On a little bit more of the meta front, we've had some new leadership come into the UAA team, and they're currently reevaluating the roadmap and how they can be a little more open in terms of collaboration on that and on development. So I think they've mostly been working with some of the folks from SAP that have also been strong collaborators on that project to drive that forward. A couple other highlights. I'd mentioned that Irene had been working on getting app tasks to run. That's still in flight, but they've also been exploring some initial CRD representations of the Irene API contents. So figuring out how that might work and move more to the domain model for CF for K8s and kubecf into the K8s API itself. A couple other things. Networking team is also finishing up some of their work to represent route entities as CRDs, and they've also been working to incorporate the latest version of Istio 1.6. And then finally, the logging and metrics team, they've identified, I think, some scaling issues around the ingest performance of log cache, and so they're working to resolve some of those. So, as always, happy to field questions about these, and everyone's always welcome to drop into the app runtime PMC meetings to talk to the leads or to engage them on Slack.
Eric, are you also have any updates from the Bosch team, or is that a different person?
That would be Marco as the PMC lead for that.
Okay.
Okay. And we've already covered the big news on extensions, which is Troy's taking over as the new CF Extensions PMC lead.
I do
Sure.
know about the Stratos release
Oh, cool.
a few days ago. 3.2.1, mostly just bug fixes. It's looking really good.
Cool. Awesome. Well, there is ostensibly an extensions PMC meeting, by the way, on Monday, Troy. We can talk about whether or not you want to hold that or defer that
Sure.
a month.
Sure.
But
No,
yeah,
I think we can go right ahead.
that sounds great. We can talk about some house cleaning and things that Dr. Max and I had planned on getting done and we haven't really gotten around to. So there's probably some projects that can be moved to the attic there. But we'll
Cool.
talk about that on Monday. Awesome.
Thanks.
Okay. Anyone else have any topics of discussion they want to jump into before we hand this over to James and Stark and Wayne?
The one question I got is, do we know what's happening with stem cells after April 2021? Because that's when the current stem cell that's just expires, basically, right? So is there any plans for the next version of stem cells?
I understand there was a posting a while back, I think probably from Brupa, asking for interested folks in the foundation to collaborate on what's that next thing. And they're still looking for additional help and interest in that.
Okay.
I'll see if I can dig up the link to the email post that describes that.
All right. Thank you.
Great. Thanks, you. All right. Well, without further ado, then we'll hand over the reins to James, and he can take us through this new project Gluon, which is seemingly very cool. I've read through the blog post and watched that video once, but he can tell you a lot about that.
Cool.
James.
Hello, everybody. Everybody hear me? Is this
Yep.
on? All right. So if you don't know me, my name is James Hunt. I'm the director of R&D here at Stark & Wayne, which means I basically ask questions and then write code to answer those questions. All day, every day. Dream job. Super glad to have it. One of the questions that was asked about a month ago was, we were talking just water cooler virtual chat. Why can't Kubernetes deploy VMs? Right? And we weren't talking about cloud provider for scaling clusters or anything that's currently undertaken by the SIGs for Kubernetes, but it was more of if I have a Cloud Foundry right now where I deploy it via Bosch, that means I have a separate set of tooling if I'm trying to move forward with Kubernetes. And we got into the technical details of operators and custom resource definitions, and it kind of occurred to us that, hey, we could just have a Kubernetes controller that runs Bosch commands and translates Bosch or Kubernetes CRDs or custom resources into all the things we expect from a Bosch-based deployment paradigm. And that might be yet another way of tying the ecosystems together, right? So you've got Irene, which is let's run CF applications on Kubernetes. You've got kubecf, which is let's take existing Bosch releases and run those on top of Kubernetes for the purpose of running Cloud Foundry atop Kubernetes. And you have CF for K8s, which is let's pick up the application-y bits and put those on Kubernetes. And what Gluon is the opposite approach of let's have Kubernetes run our Bosch stuff to tide us over until such a point as we can make the jump fully over to Kubernetes native technologies like CF for K8s, kubecf, and Irene. So I've got the slides from the video. We do have a video that I put together where I go through a more in-depth demo. If you go to starkandwayne.com/gluon, this is kind of the landing page for the whole open source thing. Kind of gives you a teaser of what we're trying to do and what the idea was, and then a link off to the video. But we don't have time to watch the video, and I wouldn't subject you to that without your consent. So instead, I'm going to just kind of quickly run through the slides just to get an overview of the architecture of how this thing is put together. And then we'll take a look at a BOSH that I deployed this morning into my Buffalo base vSphere lab. And then we'll deploy something small on top of it that won't take 3 hours to kick out. So as I said, the premise of Gluon is, what if we could kubectl instead of BOSH? And by that, I mean, let's have unified tooling for managing all of our infrastructure, whether that's containerized, whether it's VM bound or what have you. And to that end, we have to create some new custom resource types. The first custom resource type is a BOSH deployment. These are all namespaced under gluon.starkandwayne.com. So the BOSH deployment for this resource type does not conflict with the BOSH deployment from kubectl, one of the powers of versioned APIs inside of Kubernetes. So you can run both at the same time on the same cluster without any conflicts. A BOSH deployment is modeled as, what kind of *deployment are we deploying? What ops files and what vars are we specifying for those ops files and for that base deployment? The resource itself and the controller manages the state and the vars store, things that we currently kind of defer to the operator to say, hey, I generated a bunch of certs and some passwords and some other things. You need to put these safely, securely somewhere. We actually just shove those back into Kubernetes after the deployment is done. The next resource type is a BOSH stem cell, which models what OS and version and what director is this bound for. When you create a BOSH stem cell, if all of the dependencies are satisfied, the Gluon controller will go out and do an upload stem cell, downloading, verifying SHA-1s and all that fun stuff inside of a job. And finally, we have a BOSH config, which rolls up the cloud and runtime configs and lets us supply basically the whole of our BOSH configuration landscape in terms that Kubernetes APIs can understand, and then Gluon will translate back into BOSH commands. This is declarative as opposed to imperative, whereas right now, if you're deploying BOSH-based infrastructure, there's a lot of do this, then wait, then when that's done, do this and wait, and for God's sakes, don't do the second step twice because it will fail the second time. So it's not idempotent, it is imperative. This is all declarative and idempotent. It's managed for you, so it keeps track of your vars that you've specified for your deployments. It keeps track of who's where in the chain. For example, in the video demo, I actually applied all of the config at once, and the Gluon controller says, so I have a deployment for the BOSH director, I have a deployment for Cloud Foundry, I have a stem cell, and I have a cloud config and a runtime config. And it figures out the order of operations for all of those things to happen by saying, essentially, there are implicit and explicit dependencies. And we'll see both of those as we get into the YAMLs. It all starts with the actual BOSH director BOSH deployment. So demo BOSH, the stem cell can't get uploaded until the director is up. The cloud config and runtime configs also can't be applied until the director HTTP endpoint is available. And we can't really start the deployment of whatever we're deploying on top of that director until all of those dependencies are met. And the idea is, rather than burden operators with that dependency graph, that list of what needs to go when and in what order, we have the knowledge and the information at our fingertips to figure that out. So let's just let the Gluon controller do that for us. The rest of this is just going through the YAML, which I would like to instead walk you through by hand in an actual shell session. So if I can get Zoom out of the way. Zoom out of the way. If we take a look, we'll start with our director. So the director YAML, this is actually the most complicated we're going to see today. It's a bunch of different things all kind of mashed together. So we're going to start with a config map, and this is how we specify our vars files. So if you're used to doing a bosh create env -v this -v that -v, etc., you can now put those variables in either config maps or secrets. So this is a config map that lists out all of the quote unquote public information that I can show you on a recorded and sent to the internet video talk about our Buffalo lab. Things like where inside of vCenter am I deploying, what's the networking look like, where do I want to store all these assets inside of vCenter. And this is something that, because you'll see when we get into the vars, you can reuse these config maps across multiple BOSH directors or other deployments. If you have lots of deployments that are the same, you can extract the common information, the common vars out of individual scripts and put them in one config map, and then we'll map them back in on the BOSH deployment side, which is right here. So the BOSH deployment repo or kind, this is, by the way, V1 alpha. We're still playing with this. This is subject to change at a moment's notice. The BOSH deployment represents our BOSH deployment, surprisingly enough. The name will be the name that we reference it in other parts of the system. So I'm going to create a BOSH director called Cab1. I'm going to give it some arbitrary labels so I can find it with my Kubernetes inventorying software. And then diving deep into the spec, we specify where are we pulling our deployment YAMLs from. So this is upstream official BOSH deployment. Which branch, tag, or commit-ish do you want to deploy? This more useful for CF deployment where they tag versions. So you can say, I want to do version whatever, XYZ. Or if in the BOSH case, if you want to tag to commit IDs, you can do that as well. And then the entry point is what's the first YAML you're going to give BOSH create env if you were doing this manually. So for BOSH deployment, it's bosh.yaml. For CF deployment, it's cf-deployment.yaml. And this model, by specifying this stuff externally, allows us to build other -deployment configurations and put them on GitHub or Bitbucket or anywhere else and pull those down. Next up is the list of ops files I'm going to throw as -o arguments to my BOSH create env or my BOSH deploy. Because I'm on vSphere, I'm going to activate the vSphere CPI YAML. I'm not going to throw UAA or CredHub on here, mostly out of interest in speed. And then we get into vars, which is where we start mapping things back in from all the disparate locations. So we saw the cab demo BOSH config map that had all of our vCenter stuff. We also have a secret. This is my creds secret for getting into vSphere or vCenter as my deployer user, which again, because this is a recorded call, I'm not going to show you, but we map just the user key and password key from this secret in the current namespace into the var vCenter_user and vCenter_password. This will override anything that's specified in config map, and you can specify as many of these as you want. So if we wanted, I could do this. I could say config map, name all BOSHes. I could say config map, let's grab vSphere based BOSHes, etc. And then I can kind of hierarchically roll out my config with overrides at the various levels. So the vSphere based BOSHes config map might have all of the information about my Buffalo Lab vSphere environment. And then cab demo BOSH is only going to specify things specific to this BOSH director. This pattern, we use it a lot in our Genesis deployment product. It works fairly well. It gives us a lot of flexibility, and we've kind of mapped that over into Gluon. Finally, you can just override individuals. So if you don't want to bother with a config map or a secret, you can just embed a literal, this will be -v internal IP equals 10.128.16.201. And that will override anything that has come before. When we apply this, which I applied this morning, if we look at our BOSH deployments, we have cab1. And if I describe that, you'll see all of the information pretty much that was in the YAML file. That in turn, when the Gluon controller sees a new BOSH deployment that it's never dealt with before, it turns around and it creates a job and a bunch of other, actually a fair amount of other things. Namely, it creates this deploy, whatever the name was, BOSH. And if we describe that, we have a whole bunch of stuff happening in the environment. We have a state file or a state persistent volume claim for the Bosch createnv state.json file so that we can keep track of VM CIDs and stem cell information. We also have a fair amount of other secrets. In fact, let's just do a k-get-cm. Our Cab1 state and our cab demo, actually that's old. Cab1 state will actually hold the state file that's from the PVC so that we can pull it back later if we accidentally delete the PVC. But the real meat of it is going to be in that job. So if we look at the jobs and then we look at the pods, the job, we're now into standard Kubernetes territory. A job just creates pods according to a certain number of maximum attempts to retry. And it's what the Gluon controller is doing is providing all of the shell logic inside of an image and all of the configuration and wiring so that when we look at this and we do a k-logs, we have, pop that into less, we have what is basically a Bosch create env command. So here we're saying Bosch create env, we're going to do bosch.yaml with the state file into our volume, var store also into our volume, and then we're pulling all of our variables from the environment variables that are prefixed with Gluon. That's really just a implementation detail. But as you can see, we go through, this is stock output from a Bosch create env. We do our deploy, we spin up our VM, we wait for the agent, we compile, we compile, we compile, we compile, and then we're all done. And the last bit that's specific to us, to Gluon, is pulling that credentials information out of the state file and out of the var store and stuffing it in Kubernetes things, specifically a config map called Cab1 state and a secrets called Cab1 secrets. What that Cab1 secret is going to show us is all the interesting information about how do we access this. What's the CA cert? What's the the CA cert? What's the URL, the username, and the password that were generated by Bosch create env config server implementation, and we can use that in a custom CLI that I wrote called Gluon, where you pass it the name of the director, which causes it to use the currently targeted kube config with kubectl to go pull those 4 information pieces. And when we run it, it will connect up to that Bosch director and show, basically let me run Bosch commands. So I can take a look at deps. I can take a look at cloud configs. Cloud config. I can take a look at stem cells. And if I stopped here, I would have the ability with Kubernetes to deploy my Bosch directors and then use them from Bosch. But we're not going to stop there because we're going to look at our cloud config.yaml, which is a fairly thin wrapper. We say this is a cloud config, and we're going to put it on the Cab1, and then everything from line 11 on down is just a YAML cloud config that I shoved into the Kubernetes YAML as a string. So the pipe makes it a multi-line string. This will also turn into a job inside of Kubernetes, and it will have a dependency on that Cab1 Bosch director. So if we look at jobs, we have an update cloud config. I can show that. Oh, that's not a pod. That one. If there's no output because update cloud config doesn't generally do that. We also have stem cells. All right, so if we look at stem cell, the stem cell is just the things you would give to an upload stem cell, what director it's bound for, the URL, the SHA, the name, the version, and then we give it a name inside of Kubernetes for dependency reasons and because you have to name things in K8s. That in turn, as you might have guessed, creates a job. And if we look at the pod for the upload v621.74 stem cell, and I did that again, upload that one. You'll see this is just standard Bosch running an upload stem cell. And then finally, once we have a Bosch director, once we have a stem cell, once we have cloud, and optionally a runtime config, we can create another Bosch deployment that uses our Cab1 director, but with a different Bosch deployment repo. This is box deployment, which is something I spun up on GitHub. It deploys nothing. It gives me VMs. It's great for demos because it doesn't compile packages. And and I've got a couple of ops files. So you're using the same, it's isomorphic interface, right? It's the same tooling you're used to. It's the same YAML format for the most part, but now we're expressing it in terms of Bosch. And this has an explicit dependency. It will depend on the stem cell called this and the config called that before the Gluon controller will actually attempt to deploy this, which means I can take the 4 things we've looked at, the director, the stem cell, the cloud config, and this deployment, and I can apply them all at once and then go off and do something else and let Gluon figure out the order, do the right thing, babysit the jobs, pull the creds out. A side effect is because we have all the creds to talk to the Bosch director, and we know that that Bosch director is called Cab1, that's where Gluon will pull the creds when it goes to do the Bosch deploy. It will actually mount the secret into the container that's going to do the job run. And then I never actually have to know what my passwords are. They're all managed in Kubernetes if I don't want. Like I can go looking, right? I can go get secret. I can base64 decode those values, but I don't have to. So that's the architecture, and that's how the inner thing works. Does anyone have any questions or thoughts or interests or good God, why did you do this?
I'll ask that one.
Good
Why
God,
did you
why
do
did you do this?
Yeah.
Well, so Troy, I'm in R&D, so I have to do both R and D, and sometimes I don't have any ideas. The main reason I did this was CF for Kates is coming. Irene is here. CubeCF is getting better every day. But we have a lot of people we talk to who still want to run Cloud Foundry on VMs and will for a fair amount of time as long as there's support. And one of the things that this architecture allows them to do is to move forward with a Kubernetes native strategy while still maintaining their legacy Bosch environments, their legacy VM-based Cloud Foundries, with additional automation that you get from being able to create a declarative version of your Bosch infrastructure. I've seen too many ad hoc, bespoke, custom plugin or pipelines that do the Bosch rollouts, the stem cell uploads, the config management from Git and all that. This gives us a tested control plane via the Kubernetes API and an operator to do the heavy lifting of most of that and then just plunk in. If you want to upload new stem cells every time they pop, now all you have to do, if you've got the machinery that looks at Bosch.io and pulls stuff down, you can look at and just create these stem cell things mechanically, apply them to the Kates cluster, and then be done. Let the Kubernetes machinery handle the rest of it. And as I mentioned, the secrets are pivotal to figuring out how to talk to things, but the secrets they don't have to come from Gluon, right? You can just put the username, password, CA cert, and endpoint URL in a secret and then start using it from the Gluon controller, even if that was deployed via Bosch CreateEnd 4 years ago, or God forbid, MicroBosch 7 years ago. If you have the creds, you can kind of adopt Gluon and move forward and gain all that automation experience.
Awesome, thanks. I can see it being really useful for Bosch releases of database services.
Mm-hmm. Yeah, because like you could build a Helm chart that instead of ending up as containers inside the cluster that you deployed the Helm chart to, it just spins a Bosch director and then pushes more stuff. It's fascinating.
You could use Kind to bootstrap Kubo with this, right?
You could. Yep. In fact, I did the demo that this is in Kind. It's just running on my local box in the Docker daemon, and it's hitting a vSphere that's on a VPN. The Gluon hands-on lab will be doing the latter half of this exercise, where we actually start with a Bosch director and we apply cloud config and stem cells and then do some deployments of things to try and, as we also look into what the manager's doing and how the controller works. But that's all on GCP. So we use the GKE to run Gluon to then bootstrap our Bosch director into GCP's compute engine, which was pretty nifty.
You don't need any storage class for this, right?
You do, because the Bosch, well, you do if you're going to have Bosch do the Bosch CreateEnd stuff. If you're going to do the from nothing deployment of something, we do need a PVC. We need a storage class to fulfill the PVC we make for the state file. In theory, we don't have to do that. That was a design decision. And if that becomes problematic, we might change that. I just wanted to have if the pod died, and it has died repeatedly because of bad configuration and other things, that PVC, the PV behind it, sticks around so that you don't lose track of the VM you have created in a previous job.
If you could make it so that you don't need the PVC anymore, you could have like this transferable set of CRDs, right? That you can just kube control get, and then kube control apply. It's kind of like a Bosch director to go of sorts.
Yeah, like we
I
asked the
really like that.
question and thought it was silly, and then answered it, and a whole like we then spent the next Chris Weibel and I spent the next like 2 days just throwing out random things like, now that we have this, we can do this, 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 and this. It's one of those. It's a small tool, but it's a very sharp tool.
Yeah.
I think. I'm a little biased because I wrote it, but. Anywho, like I said, the video out there is me for half an hour or more, rambling, more detailed. There's a funny part about 28 minutes in, if you can make it that long. This is on GitHub. It is open source. It is MIT. I just finished putting up, or will be putting up, oh, no, here they are, the installation instructions. I'm trying to figure out what we need to do for dev and other things. So if this is interesting to you, take it for a spin. Let us know in the GitHub issues, or find somebody in Slack on CF. I'm Jay Hunt. You can DM me if you want. Yeah, fun stuff.
Awesome. Thank you, James. Yeah, super cool project. Looking forward to the lab next week. And yeah, any other questions or comments before we wrap this up? Woo! All right. Well, thank you all for joining. Looking forward to seeing you all at Summit next week. Please go register. Please go check out the schedule, in particular the hands-on labs. And we'll see you then. Thanks so much.
Cheers. Thank you.
Bye.
Cheers. Bye-bye.